Hello and welcome to the Nextflow Podcast by Seqera. You're joining us for episode 48, going out on November the 26th, 2024. Today, I've invited basically everyone I could find at Seqera to join me on the podcast, and we're going to go through and talk about all of our favorite bits from the Nextflow Summit Barcelona 2024, which was a couple of weeks ago. There's so much good content in those talks. All of them are on YouTube, but it takes you, 2.5 days to go through all those talks. So we thought we'd pick out our favorite bits for you. We're recording in two separate sessions. So I've got European folks on call with me right now, and then later in this podcast, I'm going to pull some people in from America's time zone. So, thank you very much for joining me, everyone. Should we do a quick round of introductions?
Yes, hello everyone. I'm Maxime Garcia. I've been a long-time contributor to NFCore. I love Nextflow, and that's how I ended up working at Seqera at some point. I developed pipeline, I helped with the community, and I'm living the dream, definitely.
Hi, I'm Adam. I'm a bioinformatics engineer here at Seqera in the scientific development team. Spending a lot of time doing cloud infrastructure stuff and deployments of Nextflow pipelines, a huge range of different environments.
Hi, I'm John Manning. I'm also in the scientific development team. I also do lots of customer workflow development tasks and some infrastructure things as well. Yeah.
Hi, everyone. So my name's Chris, and I am a technical writer at Seqera. So I'm a part of the education team, and I primarily focus on the Nextflow documentation.
A well-known face to this podcast audience, I'm sure. Great. Okay, the way this will work is we're going to go around, talk about a particular snippet of a specific talk, which resonated with us. I'm going to splice in the little video clip into the podcast so everyone listening can hear which bit we're talking about. So, Adam, I think you're up first. What have you got for us?
I struggled to pick out of all of the good moments that I wanted to choose one of my favorite new features, which is Wave Mirror, which I really like.
Let's watch it, shall we?
There is new container mirroring capability. That means that Wave can be used to copy containers from one registry to another. This can be useful when you deploy the pipeline across different cloud regions or across different cloud. Keep the container where the pipeline is running, so to improve the efficiency because you cache the container in the same region where the computation happens. But also for regulatory reason, it may be required that you keep the container there.
I just love this feature because it's kind of subtle and understated, but has such a big impact. Securing your Docker containers is a recurring problem that people have. Rely on these public external services. You've got to trust that someone else is doing their job right. It's just been such a thorn in the side of trying to get these reproducible pipelines. And just having a quick way of copying the containers into your own box is just going to make things so much cleaner and simpler for anyone who's working in regulated industry or just want some good security or clinical lockdown environment. So I like this feature a lot. I think it punches way above the announcement in the little talk.
We've got container.registry, right, which is what we used until now in NFCore. So you can change the base registry for all the images used within an NFCore pipeline. How is this different to that?
But currently, what you've got is you point your container.registry at base URL. So you may say Docker Hub or key.io or something. And then you go and grab all the containers from something like biocontainers or your own container registry. And then you run them and you trust that key.io is going. But with Wave and Wave mirroring, you can essentially grab those containers, slide them into your own container registry, and have a complete duplicate there. You no longer have to rely on configuration items setting exactly to the right destination. You can just sort of grab them, redirect to your own registry, cut out the middleman of key.io, and then just run from your own private ECR. So you can put everything in the right region, which then reduces cost, reduces greenhouse gas emissions, just a good thing all around.
I think that was a great pick because, yes, that was not one of the highlights that was announced, but definitely it's a great thing as well. So, I really like that. That was a great choice.
I think there are quite a few announcements that kind of slipped under the radar. There are so many that we only mentioned the big ones, and then we didn't know still the small ones are going to make such a big contribution to the day-to-day work of the average bioinformatician.
All right. Maxime, what have you got for us?
Yes, so Matisse, who's been working on an NFCore pipeline for machine learning, is explaining how deep learning is working and how an LLM and a neural network is working by showing how he trained his cat to get some food after he throw some cat food at it or not. Real throw or fake throw, and I think that was brilliant. So let's just watch this tiny bit.
At this stage, you start to throw another cat snack. So I'm going to demonstrate this live. I have a cat snack in my hand here. I'm going to throw it. Okay. You hear that the sound of the snack, it goes after the hand movement. The cat doesn't move straight away. It waits for the sound cue. So let's formalize the problem a little bit. So we have a cat here. At the top, you see the cat symbol.
So yeah, it was super fun, and I think Matisse is a great speaker. Just explaining by using his cat as an example was great.
I must admit, I was sat on the front row, and when I saw him come up onto stage, I was like, is he holding something? What's he got there? He's wearing a cat t-shirt, and then he goes into algebra in his slides, but instead of algebraic symbols, he's got a little emoji of cats and stuff like that. It's really good.
It's wonderful when people do science communication like that. They take something very removed from what they're trying to explain, and it really facilitates understanding. I think that's an excellent piece of science communication going on there.
Real empathy with the audience, right?
The questions in Slack, if I remember, were mostly about whether a cat could come back at next year's event. Chris, I believe you've got one for us next.
So one of the real highlights for me was Lawrence. She was talking about the pipeline crisprseq. For context, she'd come to me the day before in a bit of a panic saying, you won't believe it, but I haven't actually given the name of the pipeline anywhere on any of my slides. And she was wondering if she could update the slides and we're going to make that work. And then she just thought, no, actually, I'll just make it work. This is kind of fun. Let's just do it. So halfway through the talk, she says, look, I don't have this anywhere on any of my slides, but the pipeline is called crisprseq. And then she proceeds to repeat that several times. And it was just the most organic and fun way of, one, telling us what the pipeline was, how it works, some of the fun parts, but also just really hammering it home. And if you monitor the NF Core Slack as well, and the new NF Core shop, which was also announced, I think there's actually a t-shirt now that does mention that it's crisprseq. Crisprseq. And it's just a lot of fun. It was a really fun moment, definitely one of the lighter moments, but something I think was quite memorable.
You know you've done well if you inspire a meme.
Yeah, and a t-shirt.
So this is what our pipeline does. I have to admit I had a minor breakdown in my hotel room yesterday because I was practicing this talk and I noticed that in none of my slides did I write the name of the pipeline. So, okay, cool. Now that I got a giggle out of you, the pipeline is called crisprseq. It's called crisprseq. It won't appear in the next slides. It's on NF Core, and it's called crisprseq. So, like CRISPR and seq, like sequencing, like Seqera. So look it up. If you're interested, come talk to me also. I didn't put any barcode. It's like, you won't find it. It's called crisprseq.
So, Chris, do you know anything about this pipeline?
I can tell you its name. It's definitely like a highlight in that we can poke a little bit of fun at ourselves and everyone takes that in their stride. I think it embodies NF Core in a way as well, is that we do have the meme channel and people are ready for a good laugh. So for me, that was a real highlight.
I think it took real guts from Lawrence to do that as well, to just roll with it and make it into a feature, not a bug. Adam, I've got you down next.
Yeah, NF Test. I'm not ashamed of my love of NF Test, and all of NF Test is good, but I wanted to pick out a moment where he just highlighted the adoption of NF Test by the NF Core modules community. NF Test was never built to deal with a monorepo like the NF Core modules repo is, this colossal thing that can do thousands of modules. But they've adapted and they've worked with it and given it loads of features, and it's just a really good, positive feedback loop.
We analyzed 500 commits of the NF Core modules repository, and over the time, a lot of test cases were created, and on each new commit, all the test cases have to be executed, so the number of executed test cases grows with time. We saw that a lot of commits changed only one or two modules, and when we apply smart testing on this repository, we can see that NF Test automatically detects the changes on each commit and runs only the tests that are affected by these changes.
Yeah, I just think that's cool. That's a huge repository, like with so many tests, and it's so hard to keep on top of everything. Between automation and people working hard and a bunch of really cool features coming together, we're able to test thousands of things using only a slither of the resources we might need if we were testing everything at once. So it's cool. And I just love the power of community in one little snippet there.
I think this one sort of ties into a wider theme of the conference, where we had Loic, who's one of my picks for later, talking about sustainability as the keynote speaker. I feel like it popped its head up a bunch of times in different and slightly unexpected ways. People were really taking that seriously.
Yeah, I think we're all in the kind of science field to try and make things better. The point that Loic makes is that sometimes by trying to make things better, we make things worse. So it's good to try and avoid that.
Yes, I think I really like the plugins in NFTest.
The plugins are great as well. Anyone can write an extension now to NFTest. We've already taken them up and starting to use them pretty widely.
Maxime's done some great work on generating file complements, for example, to use in your tests, which is cool.
Being able to just check the content of a BAM file, so you can separate what is in the header or what are the actual reads, FASTA file, VCF file, and so on. So you can check the content of a file in a smarter way than just checking a particular line. I think this is great.
It's the problem shared. Someone has a problem and then they create a solution and share it, and so everyone can benefit. Just great.
All right, John, you've got one in the list next.
So this one's about outputs from workflows. Traditionally, Nextflow has used a system which I found quite counterintuitive when I started, which is this publishing logic, whereby you mark a file from a process as being important. There hasn't been a proper way of modeling direct outputs from a workflow up till now. And there's this change in Nextflow that allows us to do something more like what I expected to find as a newcomer.
We are redesigning how you define the output structuring into your pipeline. This new model to move away from this publish here directive in something that is more structured, but at the same time also more declarative, and enable the modularization of the pipeline. Essentially, the publish section is moved out from the task, instead in the workflow levels. It is allow us to have a better control, to have better modules that are more composable, because this information is not bind to the module itself. So we can reuse better.
It's just a kind of a cool way to bring things more forward to what I think a user would expect when they encounter a workflow system. Inputs and outputs and what happens in between should be the kind of the core of a workflow system, really.
Paolo drops the sentence at the end. It makes it more reusable. I think that's really key, because reproducibility and portability start to be a little bit easier because we've got this clear output flow, and we can start doing things like wiring workflows together. So it's a really nice feature that's coming on quite fast.
And importantly, also, this is going to be the way that you have to write your Nextflow pipeline. So whether you like it or not, it doesn't really matter. You've got about another 6 months or maybe a year to get rid of all those published here statements.
Yeah, it never made a great deal of sense that you marked individual processes as output points. It was a strange concept to begin with. So I'm very glad it's gone.
I think Paolo's talked before about saying this is a relic of DSL1. But now we've got this modular workflow system where you have emits and sub-workflows, and I think this is going to make a lot more sense to people.
There was a theme at this summit of developer experience. Like the developer experience was getting better and better. And this is just one small component that will make developers' lives easier.
All right then, Chris, I think you're up next.
So the next thing I wanted to talk about was the closing of the summit. It was the announcement of the Open Science Software Foundation. I think the better thing to do here is we'll watch the clip first, and then we can maybe talk about it a little bit afterwards.
I think in Phil's talk, you talk a lot about all of the stuff that happens behind the scenes that you don't really see. There is a lot of work, whether it's just stupid stuff like who's going to make sure that the domains get renewed, pay for the servers, make a lot of the projects kind of like happen in that way. So we've been thinking, how can we ensure that the future of those resources are built in a sustainable way? And today, I'm very proud to announce that we are launching the Open Science Software Foundation. This is a foundation which is a public good, whose mission it is to empower scientists through open source.
Yeah, so I think that was a nice way to finish the summit, introducing everyone to this idea that we want things like NF Core to last, we want open science to last, we want projects like these to be established and to be sustainable. For me, that was a real highlight. But I know, Phil, you've done a lot of the thinking behind this. Did you want to jump in on that as well?
Yeah, it was quite a strange sensation going on stage for that, because we've been talking about this behind the scenes for such a long time. This has been years in the making. And really, when we started NF Core, it was the whole point, right? To reduce the bus factor, to make these things collaborative. That's the whole thesis of NF Core, is that no one owns the pipelines. It's all about sustainability, collaboration, and this is a real milestone for that, I think. On a personal note, that was the very last moment of the summit week, and I was so tired, and I watched back the recording afterwards. It was almost delirious on stage, so I don't think I did my best performance. But I appreciate you picked a snippet of Evan talking, Chris. It was good.
It's nice to see just the future of NF-Core being a bit more secured.
And I think really the critical point is independence as well, because we've got backing already. We're supported by Seqera, and we've got other people who help out at SciLife Lab and others. But now this kind of hopefully forms the foundations for safeguarding all of that in a neutral manner.
People sometimes have a misunderstanding that Seqera is more involved in NF-Core than it actually is. I think it's really nice to underline the fact that NF-Core is its own community and it sets its own standards. And in fact, we don't always agree. There are times where we have disagreements, and there's nothing that Seqera can do about that when it happens. The community does what it needs to do. I think that's a really nice thing to underline.
All right, Adam, what have you got for us?
So Ken gave this great talk, rather controversially titled, How Not to Contribute to NF-Core. Lots of lovely, great moments in it, but I think my favorite one was the moment where he got me to rethink something that I hadn't really thought about. It's always great in a talk when you reconceptualize something you thought you knew. So, should we watch?
NF-Core has built the tooling to make code fair in a way that I don't think any other organization has done. And each of these findable, accessible, interoperable, and reusable principles have CLI commands that work for NF-Core tools. And if you set up your own modules library, you can simply add --git remote to begin using this same kind of tooling for your personal code bases that you need in your organization.
Cool, yes. I really like this. I worked a lot on the NF-Core modules repository. I've worked with people setting up their own private version, and I've also worked with fair stuff a lot. But I've never really sat down and put the two together and realized that actually what NF-Core modules was doing was implementing fair for code. It just helped me rethink everything I knew about NF-Core modules and how it works and what its purpose is. And I think he's absolutely right. It really does nail down all the major issues you need to address to do fair principles with your software development.
I was going to say, it's definitely an underappreciated feature of NF-Core that you can use it that way. It's a really good use case because it shows the power of taking NF-Core components and using them in non-NF-Core workflows. You don't actually have to use NF-Core workflows to benefit from the power of those components.
Before I joined Seqera, we were using NF-Core all the time, but just never directly on a pipeline, always with modules, always with the conflicts and stuff like that. Dark Nextflow.
I like that. Maxime, you're up next. What have you got for us?
Yes, Francesco explaining how he used Nextflow to teach bioinformatics at the master's degree in Italy. And I think it's a great one. So let's watch it.
So we really need to start from the basics here. We start by teaching them the basics of Bash, approaching the terminal, then we teach them R, and then we explain them about the containers, and we teach them how to use Docker and Singularity. Once we've done that, then we start discussing the infrastructure. We explain how to use a local HPC, and then we build on that knowledge to move on to the cloud. Once they have the foundation, then we start introducing Nextflow, and then they can use NF-Core pipelines for specific biological applications. So we basically cover three big categories: the coding, the infrastructure, and then the orchestration of the analysis.
So for me, this one was great because we do a lot of training as well. We always struggle to explain people where do we fit Nextflow. What Francesco has been explaining is that first they teach to the student like a bit of Bash, a bit of R, a bit of containerization, a bit of infrastructure with working on HPC and then working on the cloud. And that's where we put Nextflow and then later on NF-Core. Because yes, if you try to explain Nextflow to people that don't know how to use Bash and you expect them to write a pipeline, it's a bit hard to understand.
I have a complaint about this one because it makes me feel old. I was 10 years probably past my PhD or something before I discovered workflow orchestration. And they're getting it in their undergrad as it should be. And I think that's a wonderful thing.
Just showing you the layers that you have to build up. Francesco's obviously thought about it a lot.
It's a massive achievement to piece all of this together. The coding infrastructure and the orchestration into a university course across 2 semesters is a massive achievement.
Okay, next up, John.
Yeah, so this is probably the thing that makes me happiest about recent Nextflow developments. We often build containers in bioinformatics using Conda, but we just let those things build, and then we send them off into the wild, and the container acts as a freezing mechanism. And that works. It works brilliantly. It's what we do. But the problem is that if you then try and rebuild that container in a future time, or if you try and use the bare Conda environment at a later time, you get a different set of software. And that's because of transitive dependencies, the dependencies of our dependencies that can change under our feet when we build Conda environments. And what Paolo is talking about in this clip is a feature of Seqera containers or Wave underneath to provide what we call Conda lock files as part of the container definition. What that allows us to do is to rebuild the contents of that container at a later date and to build a Conda environment that mirrors the state of that container as well, so that we can have kind of a uniformity of reproducibility, so that you can get the same environment again and again and again. And that's really cool.
And the Conda file that was mentioned before. This is nice because allow us to recreate this container content, because here there is the precise resolution, each single package that is needed to recreate this environment. If you need to recreate without using the container in another environment, whatever.
So yeah, this makes me happy. The Conda lock files are actually the URIs to the Conda packages. So you bypass dependency resolution with Conda. It's quite a computationally expensive process to do that solving. It takes a while. So if we can bypass that, it also makes Conda environments a lot faster. So I'm excited about this small thing in a number of different ways. And I think it's a very small thing that could actually produce really significant gains in bioinformatics.
I think you've been complaining about that for a while. I know how much it makes you happy. I didn't realize it was such a problem until I stumbled onto it when I was trying to update some modules. The version was not the same in between Docker and Conda. When I discovered that, I was all on board with you and defending the Conda log file, and I'm so happy as well that it came.
Those URLs to the package, they also include the MD5 sums of the downloads. So you have verification of the downloads at runtime with Conda as well. So it's not only pointing to the full dependency stack, but it's also verifying every single package is exactly the same down to the byte as the original time it was generated.
And hopefully this will be part of NF Core soon as well. So we'll have them on NF Core modules, these lock files. That's cool. If you want to learn more, there's a blog out this week on exactly this subject.
All right, Adam, you're up. So this is the absolute simplest script that you can write with MultiQC. We're just pulling it in at the top, and we're calling two MultiQC functions, saying pass logs, and we're giving it a file directory, and then we're saying, great, write a report. And now, instead of doing MultiQC dot, instead of running a MultiQC command line, I can just run this script. I say Python, script file name, and this just generates exactly the same report you would normally see.
Yeah, I like this feature purely because I was going to use it. Immediately, I was like, right, there's 4 use cases here. I can immediately grab this and go. The ability to use MultiQC in your Python is going to simplify a lot of stuff. The amount of times I've had to run a tool, grab the logs, put it into MultiQC, get them out of MultiQC, and then pass them in a second Python script. So this is going to be just really useful.
I ended up basing most of my talk around that feature because although it's a fairly small change in MultiQC and it won't impact the majority of users, it's very invisible. Unless you know it's there, no one's going to use it, but it's really powerful. Just having a Python script is just, no one's got any excuses anymore. It's super easy.
And there's so many tools in bioinformatics that produce strange log output. And MultiQC is this huge repository of the ability to parse them and standardize them. So now suddenly you can grab whatever tool you want and just put it into a nice pandas data frame or something and just go.
Maxime, you're up next.
Yes, this talk was nice because we have different view of seeing like how to develop a pipeline. And Rob explained that like in his talk.
So your workflow exists on a continuum, somewhere between what I'm calling small Nextflow and big Nextflow. At the big Nextflow end, we've got workflows like the big flagship NF Core pipelines, some of the in-house production pipelines that I know many people in the room are contributing towards and running at a massive scale. Nextflow is extraordinarily flexible with many optional features. And big Nextflow has basically everything switched on. You're using all the features. At the other end, we have what I like to call small Nextflow. And to be honest, I love small Nextflow. I really love small Nextflow. There are many people, myself included, who start small, who use Nextflow to manage individual projects with no intention, really, of releasing them into NF Core or to building them into something that's going to do 100,000 genomes. It might be as simple as a single main.nf. But don't be fooled by this modest little start. Like even here, right at the very end of the spectrum, Nextflow provides massive benefits.
So yes, I really like how Rob explained how he sees Nextflow development in a continuum between like small Nextflow and big Nextflow. I can see that he sees himself on the small Nextflow side. I see myself on the big Nextflow stuff because when I start building a pipeline, I'm already thinking like NF Core, okay, so I want module, I want containers, I want CI/CD, I want NF test, I want all of the things. Rob likes to start small, and it's not a bad way to start either.
Yeah, I think this is a good reminder for us that there's this whole universe of Nextflow outside of NF Core. There are people who don't want to care about the CI/CD. They just want to get something done quickly to get their own little bit of work done. And so it's a good reminder of that.
We often casually throw out the term Nextflow scales really well. It means very different things to different people. Sometimes that means your samples are really big. Sometimes it means lots of samples. Sometimes it means a simple pipeline. Sometimes it means do a really big, complicated pipeline. And I think one of the things is an analysis. There is a little analysis that someone wants to do versus a production level pipeline. And there's everything in between. And Nextflow scales really well between those two things, as well as thousands of samples or big samples or something. So yeah, Rob highlights that really well here in this talk.
Okay, I think that's everything for our highlights. It's really fun going back through his videos. I can enjoy them again a second time. Thank you for suggesting your favorite snippets. Hi, and welcome back. This is recording session 2 for the different time zones. So I've managed to grab a different group of Seqerans together to talk about all of our favorite bits. Let's just do a quick round of introductions, say who you are.
Hey, I'm Rob Newman. I'm a product manager at Seqera, everything related to the platform. Specifically, my focus recently has been on data studios.
Hi, I'm Rob Simon, scientific support lead at Seqera. I spent a lot of time helping out people writing and executing Nextflow pipelines.
You guys, this is Sasha. I'm the product manager at Seqera. I mostly focus on growth and AI.
Hi, my name's Ken. I'm a developer advocate at Seqera, and I work with our community team, both with outreach and with academic institutions.
I'm Florian. I'm a bioinformatics engineer at Seqera, and I've recently been working on benchmarking and work with our customers to enable them to run Nextflow at scale.
Great stuff. So we've got some highlights picked out here. Ken, you're up first.
Yeah, so this was a fantastic talk from Genomics England about how they are helping people with rare diseases understand what is causing the symptoms as early as possible.
So what this kind of brings into the fore is the concept of the diagnostic odyssey. A baby's born, they may develop symptoms. At that point, they're taken to the doctor, they go to various specialists. They might undergo various tests, and this whole process can take months, possibly even years, and they may get a diagnosis at the end of that. But unfortunately, over this whole time, that child is living with whatever condition they've developed. What the Newborns Generation Study aims to do is to skip out those middle steps and it move to a much more proactive and preventative form of medicine with the aim of sequencing another 100,000 newborns here shortly after birth, looking for a list of around 200 conditions where we have quite good confidence that there's a good treatment pathway available and that if we intervened, we could vastly improve the life of that newborn baby. My team are tasked with the challenge of building a system to automatically and continuously process 100,000 whole newborn genomes over a period of about 3 years.
Yeah, so the part of Edwin's talk that I enjoyed the most is talking about the impact, where they want to shorten the diagnostic odyssey of the 7 to 8 year average timeline that it takes for someone with a rare disease to get a diagnosis that explains their symptoms. The company that I was working with before I joined Seqera was GeneDx, which is also working on a very similar study in the US called the Guardian study. What Edwin's team is working on, how do you build a system that can automatically and continuously process 100,000 whole genomes? He talks about what a modern Nextflow with Seqera platform-based system is able to deliver for them in terms of scalability, cost, monitoring, logging, and all of that.
Yeah, it was a really impactful start of his talk where he's got some case studies of real-life children that makes everything else feel a bit more real. Genomics England, it's not long ago that they ran the first 100,000 genomes project in the UK. And that was a huge effort that take years. And now we're launching into these projects where we're doing the same number of genomes and it's not such a big deal and the timelines are much shorter. And it's the pace at which things are accelerating that's phenomenal to see.
It's the first time I've heard this term, diagnostic odyssey, which I think is wonderfully evocative and a perfect term. I really love this focus on the patient experience.
There's a lot of information that we can provide people that's much more definitive than anything else that they've been exposed to before. So very exciting.
It's such a relatable thing to sequence someone's genome and then being able to tell them this is what you have. I've previously worked in a children's hospital where we worked with children with congenital heart diseases and sometimes a single variant that's causing their disease. And before genome sequencing or exome sequencing, it was really hard to identify those genetic variants. But now that we can do these screenings, we can really, offer these people like hope. You really have something that you can go to the patient and say, this is why you're sick.
And with this case study in particular, you don't even have to wait until the child's sick. You can catch those diseases before the sometimes irreversible impact starts to take hold, which is huge. You can really change lives and save lives in a way that's not possible any other way. All right. That started us off on a bit of a serious note, but let's see if we can turn things around. Florian, you're up next. What have you got for us?
Yeah, so I chose a talk from Ziad from the Australian Biocommons project, and he is showcasing some of their interactive reports for visualizing protein structure prediction from Alphafold. I've chosen this particular snippet because I think it's quite pretty and it showcases these protein folding results of how protein looks. But in general, the whole talk was quite interesting. It's just pretty to look at, right? These types of methods have won the Nobel Prize this year. So I think it's also quite timely.
Just directly from the platforms, Alphafold will produce 5 different models. The users will have a visualization of these models in the 3-dimensional structure. They can interact with them. They can see some general information about the samples, can zoom in, zoom out, rotate, even navigate between different ones. You can see the PLDDT confidence as well reflected on the structure. You could even change the representation of the models. I think 4 of them are supported.
What I really think that whole talk from Ziad highlights is Biocommons Australia really taking responsibility for driving reproducible and scalable science in Australia, doing that using Seqera platform, and also directly contributing back to the communities. So Ziad and his team, they were pushing this code to the NF core protein fold pipeline. They worked during the hackathon on this. They are giving back the tools that they're developing back to the larger community and not just keeping it for themselves. And I think that really just represents the best of the Nextflow community to me.
Yeah, I think whenever I speak to folks that are starting out, I always joke that in bioinformatics, there's this graveyard of people that wanted to be bioinformaticians, but could never get the damn thing to run or even turn on. So anytime I see stuff like this, which is more focused on, hey, how do we widen the net? Right.
And that was one of the bits I really liked of his talk, where he showed that NF core protein fold pipeline could run over, was it 3 different models, I think?
Yeah.
And then render those and also show the differences all overlaid on top of each other. Just with almost no setup and no real prior experience, you can run all these state-of-the-art models and compare them all in a dynamic visual report. I mean, that's pretty awesome.
I think it pushes other developers that are putting out models. The most impact that you can have is by contributing to this community because it's well supported. There's all these other tools that will make it easier for people to run.
My favorite thing about the talk was this looked amazing and it required no input from Seqera or Nextflow. It speaks to the Nextflow and Seqera ethos of giving scientists and researchers the tool they need to build other tools. So yes, Seqera platform could absolutely build an alignment viewer into the platform, but it wouldn't be as good as the tool that the researchers themselves have developed. It wouldn't be as good as the one that Ziad developed because research moves so incredibly quickly. So we're used to seeing MultiQC reports in the reports feature, which is great, but it can be so much more. Nextflow gives you the option to generate arbitrary reports. HTML is so flexible, and it's actually not a huge lift to start building custom things that integrate with Seqera platform and can be interactive in the way that we've just demonstrated here. So I love this. Seqera builds tools that allow people to build tools and don't dictate the sort of analysis work that you're doing.
And no lock-in, right? Because Ziad also said that this is just from a pipeline. If you run Nextflow on the command line, no Seqera platform, nothing, you get the same reports. It integrates really well with Seqera platform, but there's absolutely no requirement to use that. All right. Sasha, you're up next.
Yeah, so for me, I think that Evan's keynote with the custom environments was very cool. So yeah, I picked out this little snippet here.
Importantly, as I mentioned, the data is all mounted there. So you can see they've got iGenomes mounted. I can perform a task as I would. So I've got SAM tools, and I'm just going to do a view on chromosome 21 of data, which is in a public bucket, but I can treat it like it's just local to me here. And you can see that it's just basically treating it like that. So that's a fantastic. That's all really enabled by a lot of the fusion technology that we've been building in, but again, it makes it seamless in this way to work across cloud and across the different regions as well.
Yeah, so this was my favorite part. I think that installing stuff is my least favorite part of bioinformatics. So really anything that gets rid of that for me personally is a huge win. So just having it go from something like containers straight into something that you can run on is amazing. Bioinformaticians in the future, they'll just expect it to be how things work.
I think one of the big things for me that was really nice is Data Studios uses the Fusion file system under the hood. And this was a great example of just how fast it is. Just the ability to mount those buckets in S3 into the environment and then run a command like SAM tools and just have it just go boom, like straight through. I think that was a really nice demonstration of the efficacy and speed of Fusion. It's kind of nice to see all those things together.
Sasha, like you were saying, software with containers, I think Fusion is the same thing for data, where you don't have to think about it anymore. You don't have to know the difference between POSIX file systems and S3 buckets. You just have some data, you just chuck it into a terminal, you just try and run it and it works. Lots of complicated software making the end result very, very simple.
Feeds into this story. Scientists shouldn't have to think about infrastructure, more time thinking about the science, just like an unambiguous win.
Alrighty. Florian, back to you.
Yeah, I chose this clip from Sam Wilkinson's talk about Climb Tree. He presented how they utilized Nextflow and how they had to set up database systems to look at the COVID outbreak in the UK. The snippet itself is more of a funny clip where he's showcasing one of the reports because there's an Ebola patient that is reported in the UK. And he makes very clear that this is sample data and there is no Ebola case identified in the UK. But it got a bit of a chuckle in the audience just because of how he presented it.
And again, synthetic. No, we haven't spotted someone in the UK with Ebola, despite what that says.
So obviously that was just a soundbite. But what I really enjoyed about this talk, beside the humor that Sam put into it, is also how they name their softwares, which is all based on a popular Nintendo video game, Zelda. And he's like jokingly saying in the talk, like, yeah, he still expects Nintendo to show up and be like, you can't use that logo. But all jokes aside, scientifically, this was a great talk as well, because again, he talked about the importance of something like the COVID pandemic and how tools like Nextflow and the systems that they build around it and with it really facilitated them to do a type of monitoring and analysis of a pathogen that I think 10 years ago would have been almost impossible at the scale that they were doing it. And also how they learned the lessons from doing this. If there's ever a new outbreak of another pathogen in the future, they have these systems set up. And because of the way that Nextflow work, a lot of these things will still work in very much the same vein in 2 or 3 years as they do right now. So this reliability of Nextflow as a language, as a software, was something that he highlighted a lot, which I thought was just really, really cool.
I think it's also important that it's open. So if there's a governing body that doesn't have the infrastructure that University of Birmingham has, this is available for everyone. The CDC can run this and it will work. This isn't just reproducibility for citations.
All right, I'm going to jump into the next one. Sasha, I'm going to put you on the spot because I've picked out your talk. Let's give it a listen.
Within each individual process, you guys might notice a script testing module that allows you to test it in an AI sandbox. And we have this button here called Start Test. Should we push the button, Evan? You guys want to push the button?
Should we push the button?
Okay. All right, let's push the button. So when we push the button, what happens is that the AI spins up a micro VM that has Nextflow and Wave already installed on it. Then it goes to NF Core test datasets to find the right sample for the process, and then it writes it to a file. And what it's doing right now is that it is actually executing this code and seeing if it will actually run. So if we scroll down further, awesome.
Amazing.
It ran.
I think this is probably one of the most memorable bits of the whole week for me. There's 2 things that I love about this clip. Firstly, it made me think how much you must have practiced this with Evan.
We spent a lot of time together that week.
It was a nice dynamic and it was tongue in cheek, but I felt like I brought the whole audience along with you with that. So that was a lot of fun, the push the button thing. And then the other bit, which is you had this build up where you're walking through all the steps and explaining what was happening and you're saying it does this and it does this and it finds the test data for you automatically. And I could feel everyone in the audience going, where's this going? And then you scroll down and you see that output from Nextflow, which is so familiar to everyone in the audience, where you can see Nextflow's actually run. And I could just hear audible gasps just everywhere all around me. And I was like, yes, that is amazing.
Yeah, I think for us with that demo, we were talking back and forth whether to do it live or not. And that's one of the things I like about Seqera. There's a bit of a builder mentality, and part of building is demoing the real thing. Just looking back at this, I can hear the nervousness in my own voice where I'm like, okay, this is an AI system. And obviously I had high confidence that it was going to succeed in this specific instance. But yeah, it did end up working pretty much like how we had expected it to do. Yeah.
And if I'd been able to pick out a second clip from the same talk, I think a little bit after that, you scroll down and you're like, oh no, it's broken. Everyone in the audience is like, oh no, this demo's about to go horribly wrong. But then again, you had us all wrapped around your little finger because it was on purpose.
Wow. That one I was actually much more sure on. That one is a very consistent error that does happen for feature counts. But it's one of those things where you forget that when people come into our world, how many rakes you have to step over. So the purpose of a lot of these systems is to step on the rakes for you, especially if you're learning. I think the reason why we started off with chat was because it's a good onboarding experience, especially folks that are novices. That's the place that they'll start. And the way that a lot of the basic software in our ecosystem works is that the errors are so verbose and so scary. So that's a big focus of ours, is to make them more approachable, less scary, and so that way you can just jump in and get going.
I couldn't believe you were nervous. Like, you were cool as a cucumber, man. I was really impressed. It was really a lesson in delivering a good demo. So kudos, Sasha.
My favorite moment was when you were writing, "My boss is watching, please do a good job."
Yeah. I've been playing around with these models for a long time. And one of the few consistent prompt hacks that still works to this day is threatening the model, where you're like, hey, the application will break if this isn't standard JSON. And so that part actually improves the performance on stage.
The AI model's rooting for you as well, not just the audience. Good stuff. All right, Ken, what's next?
Next one is part of the talk from Paulo and Ben about some new functionality built into the VSCode extension update.
I left a little gift for you, which is that if you do manage to fix all those errors, you'll see this little preview DAG button pop up in front of your workflow. So should I click the button? All right. You click on that, and it'll pull up a little DAG preview to the side. So this is very similar to the DAG you can get from running Nextflow, but you don't have to run the pipeline to get it. And you notice I did this for just a sub-workflow. So you could just look at a sub-workflow instead of having to look at the whole pipeline. And it's also a much more condensed. You don't see all of the channel and operator boilerplate. So this is a way to get a very condensed description, a visual of what's going on.
Yes, so this is another one of those great should I click the button moments. This time featuring a new way to interact with Nextflow through the VS Code extension. It highlights the real power of the work that Ben has been doing, putting together a proper language server that can understand how a Nextflow workflow is composed, and then use it to pull up documentation from within the workflow about how a particular process works, or generate a DAG of a workflow before you run it. That's something that users have been asking for from Nextflow for some time, and it's great to be able to deliver that in a really developer-friendly format.
It's really good when you're exploring big workflows written by other people. So if you dive into one of the NF Core pipelines and you've got 50,000 lines of code, you can start digging into the sub-workflows and viewing the DAG for specific sections of the pipeline. And it's much quicker than reading the code. You can visualize it and get a feel for the shape of it quite quickly. I don't think this one was scripted at all, because none of us knew what you were going to do, Sasha. So that was just Ben.
It's such impressive work. It's one of those problems I assumed would be impossible. One of the greatest strengths, and also one of the common criticisms leveled at Nextflow, is its flexibility. And I always thought that a lack of language server was the price we had to pay to get all of this wonderful flexibility and developer dynamism. And it turns out, if you just throw enough smart people at it, well, one smart person in this case, you can actually get both, which is a wonderful win for the community.
One of the really cool things that was just released, like I think today, is that now when you preview the DAG, you can actually click on modules or sub-workflows, and it'll actually take you to the code. So if you're exploring a workflow and you want to see the code for a specific process, you can just click on it and it'll open that process code within your IDE, which is just amazing, which makes it even more straightforward and easier to explore code using the stack. Rather than just having to go and find that process afterwards, you can just click on it.
That's seriously cool. Okay, Rob, Simon, you're up next. What have you got for us?
So I love Fusion. Fusion is one of those technologies that I'm in awe of the engineering talent at Seqera for developing seriously impressive work. This is a commonly requested feature because, as I was talking about earlier, like a lot of the work we do at Seqera is ensuring that people can think less about infrastructure. But one of the things that has stuck for a while is thinking about instance types. You have this option when you're running on the cloud to use on-demand or spot instance types. So you have to think, is this a process that's going to run for a long time? And if it is, I should probably not have it on spot instances. And then you have to ensure that those jobs get ferried to the right queue. And you can absolutely do that in Nextflow with some dynamic configuration, and Seqera Platform supports it, but it's one extra thing to think about. Fusion snapshotting gives us the option to just run the pipeline on the cheapest instances you can, and you don't have to think about that anymore. We'll have a look at the clip and maybe we can talk a little bit more about how it works.
Spot instances is the provisioning model that more or less all cloud providers have to provide cheap computation, but with the caveat they can interrupt the virtual machine at any point in time because they relocate for another job, another customer, or whatever. It's the one that we want to use because it allows us to have much more efficient computation from cost point of view, but it works well if you have small jobs in your pipeline. The reality is that Genomics pipeline are very large job, takes hours. So you're in your pipeline, you spot instances, they get interrupted, and so Nextflow, what is doing? Restarting the task. With a few reinterruption restart, you get pipeline completed. When there is low availability of specific instance type, you burn just a lot of money for nothing. What it could be done instead is that we take the state of the computation, we save into a file, and then when the job restarts, we continue. That is exactly what we are introducing today with Fusion snapshotting.
Cool. I think this Fusion snapshotting is the first of Fusion features that's extended out beyond simple provisioning of data in efficient manners. I'm excited both for the feature in and of itself, but also what it means for the future of Fusion.
It essentially will allow you to do data studios, right? And if that spot instance becomes reclaimed in data studios, then you'll just get a snapshot created and you can just start up the data studio again and it'll pick a different spot instance. It has wide implications across the whole platform, which I think is just fantastic. And it's going to be such a cost saver for our customers.
Yeah, I think the biggest thing is one of those like basic building blocks. I'm excited to have another building block to mess around with. It opens up so many interesting product experiences, and yeah, it's just very exciting.
I saw a really nice figure where it showed the availability of spot instances on the spot market. Because when I started running Nextflow on the cloud quite a few years ago, we always ran on spot. It was a no-brainer because it was much cheaper and almost never had jobs being cancelled, or it was very rare. But the spot instances are much, much more competitive now than they used to be. So now you really are having to think twice or build in dynamic retries, because getting instances cancelled and having to retry jobs is becoming almost a certainty for bigger pipelines, especially if there's long-running jobs. And that starts to take a dent out of how cost-effective running on spot market is. This is so cool because it takes us almost back to the old days where there's no compromise. You can just run on spot without any fear of racking up unexpected costs through retries.
Yeah, it's really exciting. Would you like to burn money or not burn money?
Exactly, it's a no-brainer.
I think the opinion of the audience is very clear, because I think this was maybe the loudest cheering and excitement of people in the room from all the talks. So I think people were genuinely really excited about this.
Yeah, and we've got a private preview open for this at the moment. So if anyone listening wants to give it a try, I'll put the link in the show notes and you can jump over, sign up and try this stuff out early. All right, I've got the next one here. For this one, I've picked Lyric's talk. He's the keynote speaker that we invited to Barcelona this year. He wrote this piece of software called Green Algorithms together with Mike Inouye. And he's become a real figurehead in the community for sustainable computing. His keynote was all about that. It's a great talk. Even if you're not using Nextflow, even if you're not working in life sciences necessarily, if you're just using computing, it's a great talk, and it tackles some really interesting dynamics. The particular clip I've put in here, he demonstrates very visually using a map about the variances in carbon intensity of electricity markets in different geographical regions. Anyway, let's give it a listen.
And so we've got this electricity map, which is really interesting. They show a real time, so the map changes all the time, and it's basically the carbon intensity per country, and that's the biggest difference between locations. Let's look at a few examples. So focusing on Europe, let's say you decide to move your compute from Sweden to Poland. You multiply your carbon footprint by 46. Same hardware, same software, same everything else, just because the electricity is more renewable in Sweden and more powered by gas and coal in Poland. Okay, but that's a bit extreme, moving your compute between countries like that. Let's focus on the West Coast in the US. So we're in Washington State, and we just move between two different counties. Suddenly, we multiply carbon footprint by 9, because, again, the energy providers are not the same, and therefore the share of renewable is not the same. So that's a little bit scary, but it shows that there is great opportunity, because we are quite lucky in terms of research that you don't have to be next to your servers. So that means we do have a lot of opportunities to leverage renewable energy.
I thought it was a great visualization and a good reminder that we do have a choice in this. If you are running on the cloud, this is such an easy thing for you to change. You get that drop-down list of which Amazon regions you want to pick, and you can just move your compute around the world. It has relatively little effect on you, but it has quite a big effect on the energy you're using for that compute.
I really liked the part of his message that it isn't that you should avoid doing the high impact science that we're working on. There's so many really important things that are happening in these HPC centers. It's just being judicious and weighing those costs and benefits and being more optimal about how you request your resources. And Nextflow allows you to do that so elegantly. It's really great to have the summit for a software that makes green computing so much more accessible, having someone who is talking about the impact of that as well.
I think there's a Nextflow plugin. It's called CO2 Footprint. After you run the pipeline, it calculates energy costs. They give you an HTML report, like what is the usage, what's the CO2 emissions you're going to have running it here versus there.
Yeah, this is from Sabrina Krakow's group in Cubic and Tübingen, and it is a collaboration with Lyric. So that works by taking hard-coded metrics from Lyric's research. He's got basically on GitHub some big spreadsheets about if you're using this AWS instance type, it has this kind of CPU, which has this kind of power usage, and then a bunch of mathematical expressions which calculate CO2 emissions from that. My favorite aim for that plugin is just to make it visible. Just when you run your pipeline, say, hey, just so you know, you use this much, and then try and nudge. You had this many retries, and those tasks cost this many grams of CO2. Maybe think about optimizing your config a little bit for next time. Or say you ran on this AWS region. If you'd chosen this different AWS region, your impact would have been this many-fold less. So not changing behavior necessarily, but just informing, making it visible, and then trying to give nudges in the right direction. I can tell my dishwasher to try and pick an ecologically friendly time to run at night by looking at the spot electricity market in Sweden. So I don't think it's beyond the realms of possibility that we could build out functionality like that in the future. I would love to see that.
So I really like the talks that are very focused, saving people when they're aspiring bioinformaticians. And a lot of the stuff with NF tools is one of those. It's such a cleaner onboarding experience into our world, because the learning curve is, it's not a curve, it's a cliff, right? And tools like this is like exactly what we need to push everybody forward, right? So I have this clip with Julia showing how easy it is to create a new pipeline using NF Core tools.
We also introduced the text user interface. So now when you run NF Core pipelines create, you will see this interface, which guides you through the process of pipeline creation. You will see information, documentation of every step. You will see these kind of forms to provide all the required information for creating a pipeline. You will also see help messages describing each of the features, helping you decide if you need this feature or you can safely skip it. And finally, it also helps you create a GitHub repository to hold your pipeline, which makes things a little bit more automated and reduces the steps that you had to do manually after creating a pipeline.
So this is so much better. When I started in bioinformatics, they gave me a tome that was like this big. It was insane. The first like 3 chapters were about some NCBI module that no longer existed. And I was like, I can't believe this. And this is so much better. This is such a better onboarding experience for new users. It's an interface that if you're not a command line hero yet, you can get by. But number 2, the best part about it is it makes building things the right way the only way you know. So for new users, we really should be pushing them towards tools like this so that they build the muscle to build things in a way that people that have stepped on all the rakes know that, like, hey, these are a lot of the things that you pretty much should be doing every single time that you're starting this process.
Yeah, and I think the modularity in terms of turning features on and off and in the pipeline template is just such a valuable unlock in terms of being able to start with a very minimal pipeline template to begin with, because a lot of times, like, you don't need to be going for the full production grade, well documented NF core pipeline destined for publication in a journal. So being able to choose only the features that you need for your individual small project is something that I've felt very passionate about for some time.
Yeah, a lot of credit goes to you actually, Ken, and also Adam, the big advocates for having a more minimal template. Maxime is saying how different people have different styles, but it's this big and small Nextflow thing again. Maxime likes to go in with all the bells and whistles, even if he's just doing 1 or 2 processes. Others, such as yourself, like to just use what you need. And if you only need a few files, then that's great. And now we have that flexibility in the tooling for NF Core template.
Yeah, and it's not just like big and small Nextflow production versus my own little pipeline. It's also different fields from genomics, right? Like I had to write like image analysis pipelines in the past, and when you don't use genomics, it's really like a bit of work to start with the template before version 3 and pick out all these things. And you're doing this, and maybe you're doing this for multiple pipelines. So either you keep the work you've done once so that you can just copy this, but that's also not the way you want to do it. And so every time you want to start a bigger project, you're like, oh God, I have spent like half a day just like ripping out the roots of genomic science out there. So this template update is really also opening these templates for other fields than genomics and transcriptomics, I think, which is great.
All right. Rob, you're up next.
Yeah, I think this lends itself really nicely to follow on from this last one, actually. I really liked Ken's talk because he was saying, hey, if you are in industry, you don't have to reinvent the wheel. There's still so many things out there to help you. There were many things that I didn't actually know. So for me, it was a really good reminder about some of the functionality that NF Core offers. And also just these really concrete and tangible steps. Maybe you can't go all the way and completely open source everything, but there are avenues and pathways by which you can leverage this great body of work that's already out there. One of the things that Ken said right at the end was proprietary data does not equal proprietary analysis. And I love that.
So I'm going to talk about a couple of different options that are ways to do this, from setting configuration for existing pipelines and files, setting up version-controlled institutional configurations, best practices for setting up private forks of NF Core pipelines, writing custom Nextflow plugins that allow you to extend the capabilities of Nextflow, how to build custom pipelines from scratch, also using NF Core tooling, and finally, how to set up a modules library.
You've obviously done well, Ken, with this talk because you've been picked twice on a single podcast here.
Thank you. I mean, I've told several people who've asked me about, oh, tell me about the work trip that you had to Barcelona. It was an incredible experience, and I had the chance to give a talk that I've been wanting to give for a couple of years now. Because I think these messages, there's part of it that's specific to NF Core, and the ecosystem of NF Core and the tools that are available to really make it easier for big organizations with lots of proprietary code and data to work with best practice tooling. But then there's also the general principles of the benefits of working with open source. And that's something that the tech industry has really embraced and knows how to do well. And bringing more of that open mentality and open source thinking to the biotech world is something that I'm incredibly passionate about.
Yeah, really, really resonated with me anyway. And I think also from what I'm hearing, many other people as well.
Yeah, I think changing the mentality, because it's a culture shift, right? The culture shift becomes easier if you make it easy to do the right thing.
All right, then. Nearly at the end of our list. Rob Syme, tell us a little bit about the talk you've picked here.
So I've picked a talk from Kevin and the Quilt team, and I'm such a big fan of Kevin and everything that the Quilt team are doing. And I think it follows on from what you were saying there, Phil, about this idea that this work exists on a spectrum. You don't have to do full production scale work all the time from the get-go. I think giving people analog ramp towards production. And this particular feature that Kevin's going to talk about here, I think is a great example of that. It's very easy for a computer science person to come in and say, the correct way to do this is to write your pipeline to store stuff in a solid database that stands up and has this perpetual storage, and you have to manage this infrastructure. But it's worth it because you get the faster write and read times. It's a non-starter for a lot of people because we want to optimize for time to results and velocity of the developer experience. The feature that allows you to do queries for a tiny performance trade-off, which is, I think, in my mind, absolutely worth it for people on that spectrum.
You don't actually need one database to do this kind of querying. Like our name Quilt would suggest, we're here to help talk about ways you can stitch together data sets from many different sources. And in this case, the tool that we're talking about is a federated system like AWS Athena that can do also query on read capabilities. And those two capabilities of federating, merging queries from multiple databases or data sources, and query on read, which means you can query directly from the output files from your pipeline without actually extracting and transforming or loading them into a data warehouse, will let you not necessarily have the fastest query time, but it will give you the fastest time to your answer. So in the way that Brendan Buffler would always say, because it takes a lot of time to grow a scientist, saving that scientist time, getting that answer faster is really what we're all here to do.
Like, if you can save your scientists and researchers time, that is an easy win.
Yeah, you've got the embedded cost of doing the setup and the management work. Absolute speed of a specific query is far from the full picture.
And from the dollars and cents perspective, this stuff is really fun. Let's more of the fun stuff.
And I think Kevin understated the power of this feature. I don't think it's quite clear. It only occurred to me after the fact. This allows you to have your Nextflow pipelines dump data, like your CSVs, your counts, and in CSV files in S3, and then query across all of your runs with a single SQL statement. It's a big deal, and it requires no changes to the pipeline. Your pipeline doesn't have to know about this or care about this. There's still CSV files, so if you have downstream analysis that are not Athena, there absolutely still works. So you have all this beautiful backward compatibility, but being able to query across runs, like at this pan project view, is significant.
Athena is definitely an understated technology. It's a really good Amazon service.
Okay, Ken, you're going to take us home. What have you got for us?
Yeah, so the last clip on deck is from Geraldine, talking about some of the efforts from the Seqera community team, of which I am a member. She highlights the work in the Ambassadors Program, which is an initiative led by my colleague Marcel.
The Nextflow ambassadors are volunteers, Nextflow enthusiasts in the community who volunteer their time and effort, just spreading the word, being a point of contact to the local community, to their domain community as well. They write blog posts, they organize events, they do a lot of really cool activities that supports the community in a way that really amplifies anything that we could possibly do. So supporting them is really big for us. They're distributed very widely geographically, almost pole to pole. We've got ambassadors on every continent except Antarctica. We're working on that. So this is a program that will definitely continue to grow and nurture.
Yeah, so the part that I loved from this is just seeing the map with all of the Nextflow ambassadors across the whole globe on all 6 continents. And just knowing a little bit about some of the activities that they're working on, whether it's running trainings, attending scientific conferences, representing Nextflow and helping teach Nextflow, it's such an exciting impact. And especially that it's not just happening in the US and Europe, but also in Africa, Southeast Asia, and a lot of places with not as great access to some of these tooling. And so that's one of the really cool impacts that the community team has been working on.
Yeah, absolutely. The ambassador program is awesome. I mean, I'm an ambassador myself here in Quebec, and we're trying to establish groups that help each other. It's also a great networking opportunity to bring together these people, especially in places where Nextflow isn't as big of a presence yet. I think having people drive this, that are enthusiastic, that love using Nextflow, that want to share why it's great and why it's such a fun and awesome tool to use in your research is the best way to do it. It brings a personal connection that you can't just get by saying, here's a tool, use it, because there's people that are passionate, that are driving it.
Yeah, and it serves validation, right? They're real people. Is a sort of validation that I think is special for the ambassador community.
And one more note about the ambassador program is that applications are currently open for our next round of ambassadors, and they'll be open for the next month. So if you are someone who's super passionate about Nextflow, whether you work in industry or academia and are excited about sharing that with other folks, please go to our website, nextflow.io, and the ambassador section, and there's a link there. Especially if you are working in Antarctica, it would be really great to get all 7 continents and not just the 6. So.
All right. I think that's a wrap. Thank you very much, everyone, for your time picking out all these highlights and chatting about them. It was a packed agenda at the Nextflow Summit, and it was just so many good talks. But I'll leave that as homework for the listener then to go and dig out the full playlist. You can go to summit.nextflow.io and you'll find the full agenda, details of all the speakers, or abstracts for each talk, and the YouTube video. Or you can go directly to the Nextflow channel on YouTube and you'll find a playlist and you can see all the talks there in the list and play through. You can cancel that Netflix subscription if you like, save a bit of money. I hope to see many of you at the next summit, which will be in Boston in May 2025, and failing that, back in Barcelona in October 2025, which I'm sure will come around faster than any of us like to admit. Thanks, everyone, and we'll see you all soon.